Hello everyone and welcome to a new video. Today I'm going to show you how to solve LeetCode number 1, which is to sum. I'm going to try to make this as friendly, beginner friendly as possible. So anyone who doesn't have much experience in data structures and algorithms, or anyone who is just getting started to interview can understand this. I'm going to assume some base of foundations that you may have for solving this question and watching this video. And if you're interested in the more efficient solutions, you can skip over. I'm going to have the labels for you to skip over in the description of the video for every solution. So let's get started. So the question is to sum, and we're going to be given an array of integers nums and an integer target. The problem wants us to return the indices of the two numbers such that they add up to the target. And this might be confusing at first if you're new to this kind of questions. Then we have some more text, which says you may assume that each input would exactly have one solution, and you may not use the same element twice. And we can return the answer in any order, which is great. We have some examples here, so we're going to go quickly over them, and then I'm going to switch up to a board so we have a better view of this solution. We have the numbers example, which is 2, 7, 11, and 15, and we have the target 9, and this wants us to return an array with two numbers, which is 0 and 1, because 2 and 7 sum up to 9. And as you know, the arrays in programming start from index 0, so 2 is the index 0 and 7 is the index 1. I'm going to explain this a bit more in a bit. So that's essentially what the problem is asking us to do. It's very straightforward. And if you think about it, probably it sounds very easy, but probably once you start coding this out and thinking through how to solve through this, it's going to be a little bit more confusing. We are now in the board, and I'm going to give you a problem walkthrough before we switch up into any solution. We have here the example that LeetCode is giving us, which is an array with 4 numbers, 2, 7, 11, and 15. And the target, which is 9, right? So this is very straightforward. We have two numbers, which is 2 and 7. So 2 plus 7, this sums to 9. And that's the answer that is looking for. And we are expected to return the indices of these numbers. And the indices is just the position in memory of these numbers. So as we know, arrays in programming, and I'm going to here assume that you have a bit of knowledge into basic data structures like arrays and hash maps and some others. As we know, in data structures, arrays starts from the index 0, and that's the solution we're looking for, right? Because we are summing up 2 and 7, which are positions 0 and 1, and that's what we are going to be returning, which is 0 and 1. So that's the answer for this first question. If we change this a bit and we add different numbers like 3, 4, 7, 9, 11, and probably, I don't know, 15. And we say that the target here, it's going to be, I don't know, the sum of any of these two, for example, 20. How would you actually be able to solve this? And here I'm going to start working towards the first solution, which is going to be the brute force approach. So I'm going to write here in the top so you have a better idea what we are doing. So that's going to be the brute force. By brute force, I mean this is going to be the first solution that anyone is going to think about, or the most straightforward solution whenever you're trying to solve this problem. So the first thing you can do to find a solution in any array, you can start summing up different numbers. So for example, we have, you can use 2 pointers and then sum up 3 and 4. 3 and 4, this is equals to 7. And we know this is not equals to the target 20. So we can actually move 1 pointer to the right and then continue summing up the different numbers. So 3 plus 7, that is going to be equals to 10, which is not the number we're looking for again. So we're going to keep doing all the sums. 3 plus 9, which is equals to 12. And we're going to continue doing this until eventually we're going to hit a state where we have the 2 pointers pointing to 2 numbers that are going to sum up to the target, right? So whenever we reach this point, we're going to have 9 plus 11, and this is gonna be equals to 20, right? So we're gonna do all the sums of all different numbers, 3 with everyone to the right, and then we're gonna do 4 with everyone to the right, and so on. So that's the first approach we're gonna do, because it doesn't matter the size of the array. If we do all possible combinations, we're gonna be reaching the answer, right? Once we understand how this solution works, it's very straightforward. We're just using 2 pointers, moving them through the array until we find a valid solution. We can actually make a better example so you can actually see the whole algorithm and not only the... Now, to fully understand how the brute force solution works, we're going to do a full walkthrough of this solution, which is the brute force again. And brute force only means that this is the most inefficient way of solving this question. But if this is your first time interviewing, probably this is where you want to start, because interviewers do not expect you to find the best solution for the problem at first glance. You need to think through the problem, and then possibly with hints and follow-ups, you can actually reach a better approach, right? So for this one, we're gonna have 2 pointers, and we can do this with 2 for loops. This is very simple. And we're gonna start doing the sum ups of 3. We're gonna do 3 plus 4, and then we're gonna move this pointer because that's not the solution. We know that already. And then we're gonna do 3 plus 7, which is not equals to the solution again. This is 10, and we're looking for 11. We're gonna move this to the 9, and then we're gonna have this equals to 12. I'm gonna write that here. So that's not the solution. We can move forward. And by the way, we don't need to store these numbers. We were just making a comparison between this number and the target in each step. So that's what we were doing. So we don't need to store them up. Then we're gonna move this to 15, which is 3 plus 15. And this equals to 18. And you might be asking, hey, the numbers are actually ordered, so moving the pointers, it's going to give you a bigger number. That's true, but one of the problems statements, or one of the caveats, is that we do not know that the numbers are going to be sorted, or if they are going to be sorted. So we cannot make that assumption. That's something you want to ask with the interviewer. And for this LeetCode question, the input is actually not in order. So that's a very good point to call out. We can continue with this, and we're going to move the pointer 3 to the next one, and we're going to send this back to the next number. As you know, we cannot repeat numbers. So if we had an array with 2 numbers like 8 and 8, and then the target was 16, for example, we could actually make this by using this to 8. But if we had a single element 4 when we're looking for 8, we cannot do double pointer here and then assume this to 8. That's not allowed for this question. So that's another thing to keep in mind. We're going to continue to sum this up. So we have 4 and 7. We can put this here on the side, 4 plus 7. And as you can see, this is actually equals to 11, which is what we are looking for here, right? And as in the previous question, all this in the array you have an order, which is the same for every array. Unless you are told that there's not going to be a 0 indexed array, which is not very common, so not worry about that. Once you find the solution, we just need to return the indices and not the values of the solution. So we know that the values 4 and 7 sum up to the target, which is 11. So we need to return their indices, which is 1 and 2. So that's going to be the solution for this question. And before moving out for coding, I'm going to talk about a bit about time complexity. And I'm going to assume you have some sort of foundations already with big O. That's the name of this thing, big O. If you do not, I recommend you or I suggest you to watch a video just in this specific topic, because this is very important for interviewing at big tech. Also, there is a lot of very good resources. You can check any YouTube video, probably that's enough. Or you can even check Cracking the Coding Interview or any book you have at your disposal. Right, once we know what this big O thing is, as you can see, or as you may have already seen for the solution, we're going to be comparing every number of the array. If the solution, or if for example, if this example had a different target value, like for example, 100, there is no way we can actually format this number with the numbers we have in the array. So that's impossible. So at worst, what we're going to be doing is we're going to be summing up. Let me just grab this. We're going to be summing the 3 with all the numbers. So we're going to make a total of n sums, and then we're going to do the same for 4. And then we're going to do the same for the next number. And then we're going to do the same for the next number. And we're going to do the next for the same number. As you can see, this is not very efficient. And we're going to do a total, if you make the calculus, you're going to do a total of n squared amounts, where n is going to be the number of numbers you have in the input array, right? This array has 6 numbers. So if you made all the sums of all different combinations, you're probably going to be doing in the likes of 36 combinations. This is if you repeat the numbers and you do not start in the right, this is just assumptions. You're going to be doing a lot of computation, which is not very efficient, and this is going to be translating to big O of n squared in time complexity, right? This is important. So this is time complexity of big O of n squared, because time and space complexity are different things. As per space complexity, as you can see, we're only using 2 pointers, which is what we're moving to actually find the target. And we're using 1 integer to sum up and compare this to the target, right? So that's only 3 or 4 integers we're going to be using for the solution. And Big O only talks about how much the time or space complexity increases when the input array increases, or when the input increases, right? So if we increase this to 1,000 numbers, it wouldn't matter for the time complexity or the space complexity, I'm sorry, because we would still be using like 2 pointers and then 1 number to compare with the target, right? So that wouldn't change. So space complexity for this solution, it's actually very good. So we're going to put here space. The space is going to be big O of 1, which means this is constant. And independently of the input data we have, that's not going to change. So we're going to move into code, and let's see how that goes. Great. So now we are in the coding part of LeetCode, and we're going to be implementing the brute force approach. As already mentioned, we're going to be just comparing every number or every 2 numbers, and we're going to sum them together. I'm going to use Python since that's the most readable for all of you, and you can probably translate this to C++, Python, C# or any other language you prefer to use, right? Implementation is going to be very simple for this. We're going to use 2 for loops to compare the numbers. So we're going to say for I in range of the nums, of the length of nums. And then we're going to do a second for loop. Sorry, we're going to send this to the length of nums as well. And we're going to make the second one start in I+1, which means it's going to start the next number twice. So we don't actually repeat numbers, or we don't repeat combinations. And we don't have the issue where we're summing 4 plus 4 in the same number to get to 8. Once we have this, all we have to do is have current num, for example. I think that should be fine. That's going to be equals to nums in I plus nums in j. And then we're going to compare if current num it's equals to target, then we are going to be actually returning this because that's the correct solution. So we're going to return I and j because that's the indices. As you remember, we want to return the indices, not the actual numbers. So we're going to return the indices or the positions of these numbers. Then we can just go back, and if we don't find anything, we need to still return an array. That's one caveat of this question. So we're going to be returning that if we complete the for loop without finding anything. So I think this should work as it is. Let's see. Yeah, and you're gonna notice soon right now that this is gonna fail because this shouldn't pass LeetCode time complexity. Okay, it passed. That's fine. But as you can see, it's very slow. It's sitting in the 1.52% spot, and it's fitting 11% of the solutions. It's not great. It's very slow, actually. So let's see how can we improve the time complexity of this question. Now, to think how can we actually improve this, there is multiple ways or multiple paths you can follow. Usually, whenever you're dealing with an array question and you want to make it faster, the first thing that I recommend you to think about are hash maps. I'm gonna write the name here at the top so we have that concept. Right, and you might know what HashMap is or what a dictionary is in Python. Probably this has multiple names in different languages. But I'm gonna show you how to get to this end side before actually telling you how the solution works, so you can actually get to the solution by yourself and not only following this path or memorizing the question, because that's not gonna help you for interviews. So if whenever you're solving this question, if you wanted to solve the question in a single pass, say you don't want to use multiple pointers or you don't want to use multiple indices or keeping track of different things, or making this all-fan square brute force approach, what information, if we cross this from left to right, what information do we have at each step? I want you to think about that. So if we try to solve this out like at a single step, and we are sitting, for example, in 3, and we want to find the 11, we're going to find the solution for this 11. Whenever we're sitting at 3, what information do we have? Okay, we know that the current value we have, it's 3. We know that the target we are looking for is 11, right? So we can assume also, what do we need, right? What do we require to actually make the solution? Well, you can make that calculation by doing 11 minus the current number, which is 3, and that's going to give you an 8, right? So if we had, or if we knew where an 8 was in this array, we actually would have a solution. That's a very good insight, because the way we can keep track of that information without looking again at the array, because you're going to say, right, I know that I know that I need an 8, right? But I don't want to look at the whole array, because that would be the same as the previous response, and that's correct. We don't want to do that. So what we're going to do is we're going to create a HashMap which has constant lookups, so you don't have to do a lookup to every element on the array or in the map. You can actually just ask if one element exists over there. And if we had this structure and we had an 8 in it, we could instantly know that there is an 8, and we wouldn't need to have to look at everything. So that's the way we're going to use this to solve the question. And let me walk you through it, because this is actually very simple. Once you actually implement this, you're going to see that the actual solution, it's really easy to think about, and probably is going to help you to make or go to the solutions by yourself. So if we are sitting at the 3, we're going to do the same. So we know that the current number is 3. We know that we need 11 minus 3 to actually make a pair. So the answer for that is going to be 8, right? And we are going to ask to the hash map, do we have an 8 that we can use to make a solution? Well, the answer is no, right? The map is empty because we have just created it. Cool, so that's fine. So we don't have an 8. Now, we do have a 3, right? And this 3 could be a match for a future pair. We do not know as for now. So what we're going to do is we're going to store this 3, and we're going to store its index, because that's what we're going to be using if the 3 forms a pair with anything in the future. Right, so that we finished with the 3. We move to the 4, and we're gonna say the same, right? We're gonna say, so now we're gonna move to the next number, which is 4. Then we're gonna make the same calculation, which is 11 minus 4, and we're gonna say, okay, we need a 7. Do we have any 7 in the map that we can actually use to form up a pair? Well, the answer is no, right? We don't have any 7 in the map. So we're gonna just store the 4. We're gonna store its information in the map, because hopefully we can use it in a later pair, like after this one, right? We're gonna be moving to the next number, which is 7, and we're gonna make the same calculation. We're gonna have 11, and we're gonna rest 7 to this, and we're gonna have a 4, and we're gonna ask, do we have any 4 in the map that we can use to form a pair? And the answer is yes, we already have a 4. So at this point, we know that using the 7 we are currently in and using the 4 we saw before, we can actually make the solution. So we are going to end the algorithm right here, and we're going to return the index of the current number, which is 2. And we're going to return the index of the one we already saw before, which is 1. And this is actually a solution. You can order this because whatever is in the map, it's going to happen before of what we have in the array or what we're looking at every step. But you can actually return this as it is because the question mentions that the order does not matter, right? So that's a solution, and that's the HashMap approach, which is much more efficient. It's much more great to do in an interview because it's going to show that you understand how to keep track of the state as you are moving forward in the solution. If we talk about time complexity for this question, the time complexity is going to be big O of n. This is too big. The O is too big. Big O of n, and this is time complexity. And the reason is we are ever gonna look to one element at a time, and we're gonna only look once at every element in an array. We're not gonna look twice to any element, or we're gonna only look at every element once. And I hope that makes sense. As you see, whenever we're in the 3, we're gonna see if we can make a pair with a 3. If not, we're gonna just move forward. And that means in this specific array, we're only gonna make like 6 operations. And that's why this is much faster than the previous approach. If we talk about space complexity, there's gonna have a time complexity, a space complexity of big O of n as well. And the reason is at worst case, we're gonna store every number in the array. If we don't have any solution, we're gonna traverse the whole array, and then we're gonna store the whole numbers here in the map. So we're gonna, at the worst case, create a map of the size of the array that it's gonna sit in memory. So that's why the space complexity, that's gonna be big O of n as well. So that's the worst case for both time and space. Obviously, the algorithm can always end sooner. That's the worst case, and that's how the solution works. And I hope this makes sense. If not, maybe in the code it's gonna make a bit more sense. So let's move to the code. I will see you in a bit. Great, we are in the code again, and we're gonna be coding the map solution or the big O of n solution. And as I mentioned, this is very simple to code up. The only thing we need to keep track is the map we were discussing before. We need to keep track of the scene numbers or the scene pairs. You can name this whatever you want. Just try to make this as explanative as possible, because that's one of the things that are going to be measured in the interview. So just make sure that whatever you're writing in the code, it's really self-readable or makes sense just by reading at the variable name. Great. Once we have the scene number maps, we're going to be moving to the algorithm, which is going to be a for I in range, as we were doing before, in the length of nums. This is going to be very similar to before, but we're going to be using only one for loop. The next information we need is the number, like the needed number we're going to be using to make a pair with the current number. So the needed number is going to be equals to the target minus the number in the index we are in right now. So that's, so for example, if we are sitting in the 11 and we need to make a 15, then we, the needed number is a 4, for example, just to use this as an example. The next thing is we're going to be asking if needed number exists in scene numbers. This means we have a valid solution because we already find a pair we can actually use. So we're going to use return. We can actually return scene numbers. We're going to get the needed number or its index, needed number, and then we're going to set I here. And that should be the solution because remember the format is, the format of the map. I'm going to write that in top of the map. That's going to be equals to the number and its index. So that's the format. If we don't find the valid solution at this step, we're going to save the current number in the scene numbers because, we have seen this number already. And then we're going to set this to its index so we can actually know the index or the position where this number it's located. Then if we don't find anything, we're going to just return an empty array because we don't have a valid solution at this point. And I think this should work. Cool, this worked. And if you watch the previous solution, you're going to see that this is much, much faster. We were sitting like in these places before, and right now we're in 100% bidding score. Just to clarify, there's going to be time complexity of big O of n, and then there's going to be a space complexity of big O of n as well, because we're going to be using n space for both time and space for the array and the map. Now, this is going to be a bonus solution for this problem, and this wouldn't apply to the LeetCode problem, but let me explain a bit. As I mentioned before, the LeetCode problem states, or it's not stated, but it's in the input that you're given, that the input it's not going to be in order, it's in order, right? Cool. So we know this wouldn't apply to LeetCode solution, but this would apply to different cases, right? Because even if the answer is not sorted, the solution, if you haven't thought about it or if you haven't think about it, it's going to be about sorting. So that's what the solution is going to be about. So we're going to be using sorting to solve this question. Even if the input is in order, or if it's already ordered, you can use both cases to solve this question. First, let's suppose that the input array it's not in order. We can create a new array, which has different numbers like 4 and 2 and 3, and maybe you're looking for I don't know, 10, for example. That's the target you're looking for. Even if this was not in order, if you would actually to order this array, you would have something similar to this. And probably you're asking, hey, independently if I can order or not the array, what does that have to do with the solution of this question? Well, if we were to know that the input array is already in order, or we can order it by ourselves, we can actually use that information to have a solution or to find a solution for this question. Once we have the input array in order, like the ones we were using before, those were already in order, we can actually use 2 pointers and use no extra space to actually find a solution. If we were to use 2 pointers with sorting, we could easily find a solution. And you saw that I write some arrows here in the screen, but let's think about how we're gonna find the solution. If we think about the order of this array, we know that the biggest elements are at the end and the smaller elements are at the beginning. If we were to find, or we wanted to find the bigger number, we can always look at the right of array, because the right side is always going to contain bigger numbers. And if we wanted a smaller number, we can always look to the left, because that's always going to have smaller numbers. So using that information to our advantage, we can actually use 2 pointers and be actually moving these 2 pointers to the left or to the right to find a solution, right? So if we have this like it is, and we sum up these 2 pointers, we're gonna have 18, right? 18 is bigger than 11, so we need a smaller number. How do we get a smaller number in this case? Well, we can move we can move the right pointer to the left, and that's gonna give us for sure a smaller number. So if we do that and we move this here, now we're gonna have an 11 and a 3. That's gonna sum up actually to 14. And 14 is still bigger than 11, right? But we're getting closer. So we can actually move this one more time. Sorry, I deleted that. We can move this one more time to the left, and that's going to give us even a smaller number. So if we sum up 9 and 3, that's going to give us 12, which is still bigger than the 11 we're searching for. We can move this one more time, and then we're going to be in the 7. Whenever we sum 3 plus 7, that's going to be equals to 10, which is actually smaller than the solution we're looking for, right? 11 is bigger. So we need a larger number. How do we find a larger number? Well, we could move the right pointer to the right, but that would give us a solution we already seen, right? We already saw 3 plus 9. So what we're going to be doing is we're going to be moving the left pointer to the right. And that's going to give us a different number. So 7 plus 4, it's actually equals to 11. And 11, it's equals to the solution we're looking for. So that's essentially how we can actually use sorting to solve this question as well. Now, this solution is not applicable for the LeetCode solution, because LeetCode is asking you to return the indices. And if you change the order of the array, that's going to miss information of the indices, right? So if we had, say, an array like the following, we had, I don't know, 3, 6, 7, and 1. And we were trying to find the solution for this question, and we were to order it. Once we move the elements, I'm sorry for this looked so bad, but this is the original order, right? So we're looking for the indices in the original order, and that's going to be different of what we have here below. So this wouldn't apply to LeetCode because we are going to be missing the order, but an interview, that's going to be a very good approach. And I really suggest you trying this out. You can actually make your own test cases, and you can write this in Visual Studio or whatever, and you can actually give it this a try because it is a good solution for this question. Great, now we are back on LeetCode, and I'm gonna give you an example of how this new algorithm would work. I created some sandbox test cases, which is gonna be sorted always, and that's great. This wouldn't pass all test cases because this is assuming that the input is sorted. So this is just an example for interviewing and not for LeetCode solving. Now, once we know the input array is sorted, we just need to have two indices, which is one pointing to the left section of the array, which is going to give us a smaller number. And then we're going to be pointing the next one to the end of the arrays, to the last number. So that's going to give us a big number. So we're going to be moving this pointers until they are in top of each other. And that would mean that we don't have a solution, right? So we're gonna say current number, it's gonna be equals to nums in left plus nums in right. And then we're gonna say if current number it's equals to its target, then we found the solution, right? We can return the indices. And this is always true, only true if, this is already in order, right? You could, in theory, store the order and then sort the array and those things, but that wouldn't work for this situation. Then if the current number it's bigger than the target, we can actually we're gonna need a smaller number, so we're gonna move the right pointer to the left, and then if we need a bigger number, we're gonna move the left pointer. If by the end we don't find any solution, we can return an empty array, and this should pass the 3 test cases that I created that are making sure that the input is in order always. And you can see this passes this inputs. This would have failed the other test cases because not everything is ordered. But this is one example that you can always take to the interview. And if we come back here and think a little bit about time complexity, if the input array was already sorted, we can probably say with confidence that the time complexity is going to be in the likes of big O of n, because at worst we're going to be looking at each element of the array once, and then the space complexity it's going to be big O of 1, because we are only using 2 pointers for searching for the solution, 2 pointers plus the integer that is the sum. So this probably would be the best optimal solution. So if you are in an interview and your interviewer asks you, hey, can we do better once you are working in the HashMap solutions, you can probably always think about sorting. And even if you're in the same question and you are getting asked, hey, can we do better? And you are sure, you know that the numbers are not in order, you can always sort the numbers, and that's gonna cost you big O of n log n, which is the cost for sorting numbers. If you're more of a beginner and you do not understand these topics, with time you can probably get a better idea of how this is or how this works. There's a little bit more advanced, and if you're probably interviewing for internships or lower positions, you probably do not need these topics. But this is always great to know, because even if you sort the array and that's going to cost you O of n log n, space complexity is still O of 1, so you can probably make some trade-offs. Interviewing is always about making trade-offs, so just make sure you talk this with the interviewer. So this is it for this video. If you like, make sure to like the video and subscribe to the channel. I'm gonna try to make more videos about some other LeetCode questions, so thanks for watching.